Sup, skis homies. Today I want to talk about one of my biggest passions. In fact, my biggest passion, coral reefs. So many people don't realize just how important coral reefs are to every one of us. And before I even get started on this video, I want to throw a little statistic out there that will make you understand just how important coral reefs are to everyone. So even if you're watching this video from Kansas, listen up. There is on average 700 million people per day that eat due to coral reefs existing as a either direct primary or secondary result of a coral reef. So think about that, guys. There are about 7 billion people on the planet. We're reproducing so fast I can't keep up with the number. But let's say there's 7 billion people on the planet. Maybe it's getting closer to 8 now. But 700 million of those survive on coral reefs to eat. You know, even if you're watching from Kansas, there's only so many cows we got in Kansas, right? You know, what are we going to do when a seventh or an eighth of the population in the world no longer has food to eat? You know, we know that when we get hungry, we start acting like Joe Pesci from the Snickers commercial. Like, what, I'm here to amuse you and make you laugh? What do you mean I'm a funny guy? How am I funny? We get hangry, and we can get violent as a result. For an example, you know, we know this. The American government sent up a green seeker technology satellite. I used to use this same technology in agriculture later in life, but the first green seeker satellite that went up was due to the Cold War with Russia. And we would actually use this satellite to spy on their food. We would spy on their fields, their crops. And what this satellite did was it would read the levels of chlorophyll in different crops. Chlorophyll is what makes a plant green, okay? So they would get this number and then plug it into an algorithm equation, and they could basically predict the yield off of that field. Sounds like Dr. Seuss, didn't it? So imagine that. When we knew that Russia was going to have a bad year on corn, you know, we would opt to lower our prices of corn for Russia, hoping that there wouldn't be any more animosity between us that might provoke a war. You know, so it's very important to think about that. Save the reef, you save the food. Save the food, you save the peace. Keep that peace. You know, so I am from Kansas, for example. When I throw out little shots at Kansas, I'm not talking smack. I'm from Kansas. But when I was younger, I'd see the bumper stickers, save the rainforest. Cool, you bet, got it. I'd see the bumper stickers, you know, save the ozone layer. Oh yeah, you got it, you bet. But when I'd see a sticker that said save the reef, you know, it's like, well, what's a reef? You know, why? Why do we need to focus on saving some colored rocks that some hippies out in Florida like to go swim around? Like, you know what I mean? I didn't understand it. So let me break it down to you a little bit. Before I talk about what a coral even is, coral reefs are an entire ecosystem where corals are the foundation. So, coral reefs make up about 0.01% of the ocean. You know, it's less than 1% of the ocean, but they are home to 25% of the species who call the ocean home. You know, so imagine, like, less than 1% of my body is like my fingernail, my pinky nail. Why would 25% of my coolness and my radness want to live right inside my pinky nail? Like, what's going on in there? You know, and it's all these corals. Some of them grow like this, some of them grow like this, some of them grow like that, some of them grow like this. And all these cool different formations provide habitat for fish. You know, so what is a coral? A lot of times people ask me, hey, Captain Planet, what is a coral? Is it a rock? is it an animal? Is it a bacteria? Is it a plant? And I'm just like, yeah, it is. So it's an animal, right? And I've gone through this in a little bit with other videos, but this animal, that's closest relative would be the jellyfish. Every single little dot that you see on a coral is a different polyp. Now, this polyp is like its own individual being. They each have their own stomach, their own mouths, their own stinging tentacles that come out and attack its prey and take it back in for their own individual stomachs to digest. Think of it like a classroom of children when you're seeing a coral growing over a boulder or something like that. Each little dot is a child in the classroom. So they have a special relationship with algae, though. A certain kind of algae, my homie Zooks, his real name is zooxanthellae. Some people have a hard time saying that word, zooxanthellae, especially the kids. So when I teach the kids, I just call them Zooks, because then the kids can feel involved because they have no problem saying Zook, where a lot of kids don't even want to try to say a sentence that would involve zooxanthellae, knowing that they're going to get it wrong and someone in their class might laugh, so I simplify it down for the kids so that they can get involved in the conversation and be able to ask questions, so let's just call them Zooks for everyone. My homie Zook, long time ago, he came up to the coral, right? And he's like, what's up? And coral's like, hey, dude, if I made a hard calcium carbonate hotel, would you want to pay the rent and paint it for me? And Zook's like, yeah, actually, I'm always living inside like jellyfish like Cassiopeia, getting eaten by sea turtles trying to catch a buzz. I would definitely love to live in a hard calcium carbonate hotel. So calcium carbonate is what the coral's skeleton is made out of. That's what makes it like part rock, okay? Limestone is calcium carbonate. Just to put that in perspective, as far as it's the same thing, so it's kind of like they're made out of limestone. Why Florida's all limestone underneath is, think of it like an old coral reef, and sand and all this and that. It's limestone, it's calcium carbonates. So imagine, instead of living in a soft jellyfish like Cassiopeia, where Zooks also lives, to give that jellyfish 60% of its life that it needs to survive, the energy that it needs for its life, Zooks, zooxanthellae, decides he's going to move into the coral, to this calcium carbonate resort hotel. And he's going to pay the rent, meaning Zooks now gives the coral 90 to 98% of the energy that the coral animal needs to survive, simply by soaking up the sunlight photosynthetically and creating an energy to then give to the animal coral. So think about this. The coral is an animal, and it's also like a rock, and it's also like a plant, and it's also like a bacteria. It's really, really, really cool. There's a lot of neat stuff going on there. So the algae moves inside, pays the rent, meaning he's given 90 to 98% of the energy that the coral needs, and he's also painting the house. And what I mean by painting the house is all color that you see in all coral, whether hard or even soft coral, comes from the algae zooxanthellae, aka Zooks. So they are tighter than Garth Brooks's jeans, okay? Like one of the most hardcore symbiotic relationships on the planet. But now that symbiotic relationship is failing. We are experiencing what's called coral bleaching. Now, what do you think of when you think of bleaching? Like, have you ever got bleach on your shirt? What happens? It takes the color out. It turns white. So you might see sometimes corals that have died long ago and washed themselves up to the beach, and they're white, as they're out drying on the sand. And when you're seeing that on the reef, that's not a good thing. That's not typically normal. So what's happening is now that you guys understand the biology of corals a little bit, as far as that relationship that they have with Zooks that's tighter than Garth Brooks's jeans, now you realize with this coral bleaching, it's actually like an algae problem that becomes a coral problem. You know, and why? It's getting too hot, too acidic, too fast. You know, the reason why over half of our coral reefs have died on planet Earth since the 80s, and the reason why most scientists predict that they'll be extinct by 2050 is because of climate change. And it's because of ocean acidification. You know, but we need to get ourselves squared away on some things. You know, because let's say someone's watching and goes, I was enjoying this video till he said the double C word, climate change. You know, and I understand your guys' frustrations, because everything that you've ever read about it is almost BS. As far as you guys read what the news puts out and what the media puts out. Like, you guys read Facebook articles. You're not in the actual studies. You know, so I've got a chance to learn it at a different level. You know, and let me just throw in, you know, even though climate change is very, very natural, and it happens, like when the dinosaurs were alive, like it was a global warming. When we came along, it's what we called an ice age. But we also know that Earth isn't, you know, a few hundred years old or something. We know that there's been way more than just one ice age and way more than one tropical age. So the Earth warms up and it cools down, warms up and it cools down, warms up and it cools down. We're now back on a warm up. But think of it like this, guys. Corals have been around for over 500 million years. You know, they're like the gangsters of Earth, you know, because every time there's a mass extinction, they're like, forget about it. Don't worry about us. Corals do not give a crap about sea level rises and this and that. Like, when you guys drive in the Keys, when you're in the Florida Keys, when you're walking on land on the Florida Keys, what you're walking on is the reef when the dinosaurs were alive, and the water would have been 20 feet above your head. That's why the Florida Keys and the Florida Atlantic Barrier Reef look like they're a double lane highway, because the reef literally just slowly walked 7-8 miles out into the Atlantic side as the sea levels, you know, started to drop in the ice age. Ice stacks up on top of each other as glaciers in the north and south, right? And that makes the sea level lower, you know, and it's starting to rise again. No, not all of that is our fault. I'm not saying it is. What I am saying is, if we have a fossil record of corals being around for about 550 million years, why are they dying during this time? Because it's their first climate change with us humans, and we've made it too hot, too acidic, too fast. You know, so when, you know, I taught you guys about calcium carbonate, what the corals are made out of. This is what shells are made out of, like all of our mollusks and gastropods and stuff like that. So think of it like this. When we drive our cars and power our factories, we emit CO2, carbon dioxide. Yes, we are getting a lot of misinformation about carbon dioxide, but I'm going to spit you some straight science. Don't pay attention to the fancy words. Just stay with me, because they'll kind of sum it up. So when you have CO2, carbon dioxide, forming over H2O, water, what happens is a chemical reaction. What happens is the formation of what we call carbonic acid. So this carbonic acid directly competes with calcium carbonate. You know, it's like, think about it stealing molecules out of the ocean that the corals and the shells need to support themselves. You know, so it's making it very weak. So the algae zooxanthellae with the coral bleaching, when we get overworked and overheated, what happens? Our work efficiency goes down. That's why when you work for a boss, he gives you 3 breaks a day kind of thing. because like we know this. So Zooks, think about this. He's in the coral working away like he always has, but man, it's getting really hot really, really fast, and it's getting acidic too because of all this carbonic acid. So he's not feeling so hot, so he's not working as hard. And now all of a sudden he goes from 90 to 98% efficiency to, let's say, down to 60% efficiency, which wouldn't maybe necessarily kill the coral for a while. But what's happening is the corals don't have a brain, but they react no differently than an elm forest will react when it senses an elm disease and will drop its leaves early that year to lower the likelihood of the disease transferring. The corals do a similar thing. So when they're used to this zook, the zooxanthellae algae, producing 90 to 98% of the efficiency that they need to survive, and then it drops to 60%, the coral reacts. The coral reacts because it thinks it's sick. It thinks that there's a disease. And the corals have a reaction as a defense mechanism when they sense that disease, when efficiency lowers. Think of it like the thermostat in your AC. When it gets to a certain point, it kicks on, right? So this kicks on, this mechanism. And what the corals do is they spit out everything inside of them. Everything. Even zooks, even the zooxanthellae that gives them color and gives them 90 to 98% of the energy that they need to survive. So they turn white and they basically go dormant. They do this to try to not die of the disease and to try to not spread this disease to their homies that live right next to them. You know, because it's like a classroom of kids that care about each other, right? They don't maybe necessarily care with feelings, but their mechanisms are designed to care because caring is evolving in this case, meaning, you know, only the strong survive. So if you don't have that mechanism, how could you be strong? The corals have not too long to live after that. You know, we thought that it was about 3 to 5 months that a coral could live after bleaching. But we're now experiencing even lower results because in a warmer, acidic ocean, a lot of these corals are kind of in shock. So the zoox moves out because he gets spits out, right? Well, think of zoox like a good old Kansas country boy like me. He's honest, you know? And darn it, when the coral invites him back in, saying, hey, do you want to pay 90 to 98% of my energy and I'll let you live in here? Think of it like Zooks is too honest to make the deal because he knows he can't produce that efficiency, you know, because he's too hot and he's too acidic. So the zooxanthellae's not coming back inside of the corals, and our corals are dying. You know, over half of the Great Barrier Reef is now dead. And a lot of my colleagues over there are telling me the numbers more realistically, about 3/4 of the reef is dead. You know, thankfully, there are people out there like Dr. Coral, one of my dear friends, Dr. David Vaughn. He's not only my friend, he's my hero, you know. So this guy started figuring out how to grow back the reefs using what we call microfragmentation. And we can literally reskin the reefs faster than they are dying. We can do in 2 years what takes nature 800 years to do. It's pretty incredible, you know, and we're going to plant millions and millions of corals to try to save this planet. Because think about that. Coral reefs feed 700 million people per day. Save the corals, we save ourselves. All we're doing is producing more and more people, but less and less food. Things are no longer going to be adding up, and we don't want anybody hangry out there, right? Let me know in the comments if you guys would like me to get any more specific on some certain things, maybe like microfragmentation. And I'll do just that because coral reefs are my passion and drive for a living. Thanks, guys. Peace.